Hi, this is the SJC Roof Rack Assistant designed for ME154.
I'm Zichong.
I'm Ashkan.
I'm Victor.
I'm Mohammed.
The current issue with roof rack storage containers is that loading it while it is mounted to the car is very difficult and impossible for shorter people. Mounting the container can also be very difficult if there isn't a friend to help you.
The purpose of the Roof Rack Assistant is to load a storage container at a level lower than the roof and then use the mechanism to lift it on the top of the car.
The mechanism utilizes a slider in order to move from the closed position to the open position.
Using the mobility formula, we found our mechanism uses 2 degrees of freedom. Throughout the kinematic process, we wanted the output link to be parallel to the ground at all times, from the open position to the closed position.
We initially loaded the mechanism with 50 newtons of force in 4 different locations on the output link. That came to an equivalent of 200 newtons throughout the whole mechanism. This analysis, we evaluated the highest amount of force would be located between the slider and the guide rail with a torque of 171 newton meters. We calculated that it would take 450 watts to move the mechanism from the open position back to the closed position.
The stress analysis was performed in the open position because that's when the highest forces are present. The stress was focused on these 4 joints because of the high moment caused by the load. We used the von Mises theory to determine failure mode because this is a ductile material. This material is aluminum 6061. A factor of safety of 2.5 was established.
As you can see, the project was able to carry a 5-pound load, which is our scaled down value of force, and take it back to the closed position. Due to machining errors, the mechanism deals with a lot more friction than necessary when moving from the open position to the closed position and back. This issue can be eliminated with more precise machining. Adding bushings or linear bearings could help decrease friction and allow the mechanism to move much smoother. As you can see, the rods are easily bent, which causes it much more friction than needed on the slider. Stronger and smoother materials like stainless steel rods would allow the slider to move much more freely. To optimize the mechanism, a motor and lead screw can be added to allow the user to move it between positions with minimal effort.